Hello dear students, welcome to our YouTube channel Science GK Facts. In today's class, we are going to learn one of the most interesting topic, that is electricity. In our day-to-day life, we have been using so many electrical gadgets which run based on electrical energy. From the earbuds that we use to hear the music till the trains, we are using this electric energy to run that. Even in big industries and factories to run biggest machines, we are using electricity. And in hospitals we are using, and in school buildings we are using the same electricity. And in households to run so many electrical gadgets such as refrigerator, fan, washing machine, TV, mobile, laptop, so many electrical gadgets we are running. That is why we need to know little more about electricity. See, let us come to know about electricity. Before learning what is electric current, we need to learn some of the basics which are required in order to define electric current. So if you want to know what are those basics, first we need to know what are atoms, what will be there in atoms. See, according to John Dalton's atomic theory, the first point says what? The matter in the universe, it is made up of smallest indivisible particles called atoms. So let us take an atom here first. This is the structure of an atom. Now at the center we find this mass. It is called what? Nucleus of the atom. This nucleus contains two types of particles, which are the positively charged particles called protons and neutrally charged particles, means they do not carry either positive or negative charges. They are neutral. Neutral particles are called neutrons. Protons and neutrons are present in the nucleus of an atom. Next, coming to another type of particles, they are called electrons. Electrons are called negative charges. Here, these electrons are revolving around the nucleus in an atom in a particular orbit called energy levels or shells, right? We know this just about an atom. Now you see, all these particles are called what? Charges. If they are positively charged, they are called positive charges. If they are negatively charged, they are called negative charges. Then electric current, how it is generated in a metallic conductor? See, here when electric charges, when they flow from one point to another point, for example, this is a pipe here I have taken. Let us imagine this is a metallic conductor. From one point to another point, if one electron moves, that is what? Electric charge is moving, we can say. Okay. Now, many electrons, when they are moving, they form a current of electrical charges. That is giving us what? That is constituting electric current. Current means what? It is flow in a bigger number there. So many particles together, when they move, they form current. Okay. What are moving here? If electrical charges, if they are moving, electrons, they are moving. So that is why that is called electric current. We call it as electric current. Take for example, in this only. This is pipe. If the water is passing through this pipe, it forms what? Water current. Now, if this is the metal, then if the electric charges, if they are flowing from one point to another point, they form what? Electric current. Now, let us know about what is charge, how it is measured here first. Now you see, the electrons, if you take, it is negatively charged particle, right? Now, how to measure the charge of this an electron? See, the charge of an electron, it is measured, some unit must be used there, right? If I say just number, for example, an electron is having the charge of 1 charge, 2 charge, 3 charge, there is no meaning for that. We need to use some of the units for that. The SI unit which is used to measure a charge of an electron, that is what? Coulomb here. That is coulomb. Then what is the charge of an electron then? See, here 1 electron. What is the charge of 1 electron? 1.6 into 10 to the power minus 19 coulomb. This is very much smallest value. You cannot take it even 0.1 also. Very much smallest value it is. See, this is what charge of one electron. Now, what is 1 coulomb then? See, charge of one electron is this much coulomb. 1.6 into 10 to the power minus 19 coulomb. 1 coulomb means how much? See, when there are 6 into 10 to the power 18 number of electrons, these many electrons, each electron carrying 1.6 into 10 to the power minus 19 coulomb into these many electrons, when it is multiplied, that much charge, it is called 1 coulomb. So what you can say, 1 coulomb of charge is nothing but 6 into 10 to the power 18 number of electrons, each carrying 1.6 into 10 to the power minus 19 coulomb charge. When it is multiplied, what value it gives? That is equal to 1 coulomb of charge. Okay, so this is what we have learnt is, what is the charge of an electron, what is 1 coulomb we learnt, and what are charges we learnt, what are positive charges, what are negative charges we learnt, right? Now, let us come to know about what is electric current then. Now, it supports our understanding in a better way. You see, here, electric current means what? The amount of charge. See, how much amount of charge? The amount of charge flowing through a particular area in unit time. In unit time, how much amount of charge flows through a particular area? That is what? Electric current. Electric current. In order to understand, let us take the same example. Here you see, here this is particular area. Okay, this is area of cross section. You say, for example, through this, if the water is flowing, say for example, for 1 minute, water is flowing. How much water it is passing in 1 minute through this area? That is forming what? Water current. Okay. Then, if this is a metallic conductor and this is solid one, then through this cross sectional area, if electrical charges, if they are flowing from this point to this point in unit time, so what do we say? This is what? Electric current. So how to say that? The amount of charge flowing through a particular area in unit time, that gives us what? Electric current. You have understood already now what is charge. Okay, those charges, they will be flowing, right? So how much charge it is flowing there? That amount of charge flowing through unit area, unit time through a particular area, that gives us what? Electric current. That electric current, it is shown. How it is shown here? I is equal to Q by T. Means what? Q. Q is what? Charge. What is the SI unit of charge? It is coulomb. Time. What is the SI unit of time? It is second. Right? So I is equal to Q by T. Means what? In unit time, how much charge is flowing? So that is why we are taking this as Q by T. In unit time, how much charge is flowing through that particular area? That gives us electric current. Right? Now, you see, this electric current we have to measure. How much it is for measuring how much water is flowing, meters, it is already installed at our homes, right? In the same way, this electric current, when it flows through a particular metallic conductor, then to measure this also, there is one unit called what? Ampere. That ampere is named after a scientist by name Andrew Mary Ampere. Okay, it was named after him, after his invention. Then, what is ampere here? He gives here 1 ampere means how much he gives, the value. What he gives here, for 1 ampere, here 1 coulomb of charge, if it passes in 1 second through particular area of any conductor, then the current, that electric current is how much it is? 1 ampere. See, 1 ampere current means what? In 1 second, 1 coulomb of charge, it has to pass through that particular area. See, that is called what? 1 ampere. And you have to be very much clear here. Don't get confused about coulomb and ampere. Coulomb is SI unit of charge, it is just. Means what? To measure that charge it is of electrons. But electric current is different. In 1 second, how much coulomb of charge it is passing through a particular area, that gives us what? Current, electric current. That electric current is measured in terms of what? Ampere. The SI unit of measurement of current is what? Ampere. Then we have to use a special device to measure this electric current, right? What do we use? Ammeter. See, ammeter is used for measuring the electric current flowing in a particular metallic conductor. That is what? Ammeter. This current, we cannot measure it all the time in terms of ampere itself. Sometimes smaller currents we need to measure. Okay, so that is why the current, it will be measured. If it is smaller, that current is measured in terms of milliampere, microampere or nanoampere, right? See, so this is all about what? Electric current. What is the device used to measure that electric current? That is ammeter. What is the SI unit of electric current? That is ampere. What is the SI unit of charge? That is coulomb. Okay, so all these terms we have learned already. Now we can understand what is an electric circuit. So let us come to know about what is an electric circuit. See, just you recall your previous classes, what you have learned already. An electric circuit, it is what? A closed conducting path of electric current through a switch, a bulb and a cell. This is what? A simple electric circuit that you have studied in previous classes. Now I have drawn here another electric circuit which consists of a bulb, an ammeter and a plug key and a battery. What is battery? A combination of two or more cells, that gives us battery. Battery is what here? It is source of electricity for that. Now you see, here ammeter, it is connected in series in the circuit here. We are not connecting parallelly. Parallelly means what? The two terminals of the ammeter, if they are connected across the terminals of the cell, then it is called parallel connection. Now what we have done here? Series, in series we have connected. One terminal means in between the circuit we have connected that, not across the terminals here. So this is in series connection. Now what is the function of plug key? That then plug key, this is K means what? Plug key it is, or switch we can say. This plug key, it is used either to make or break the path of electric current in an electric circuit. Sometimes we need to operate the electrical appliances, sometimes we will turn off them. So to make the path of electric current, to operate that or to stop that operation, then with this what plug key will be used. When it is inserted, it is on, plug key. When it is removed, the plug key is off, we can say. In place of this, we can also use a switch also. Switch, sliding switch is there again. So many types of switches we can see here. Now this is what a function of a switch or plug key. Okay, what it does, either to make or break the path of electric current in an electric circuit, a plug key is used. Okay, now let us come to know about these two things here. What? Here arrow marks are shown. What are these arrow marks? What are they denoting here? It is showing the direction of electric current. What it is showing here then? It is showing here from positive to negative terminal, the electric current is flowing, it is showing, right? But you see, electric charges means what? Electrons will be moving. Nucleus of an atom will be there itself, right? Only electrons will be in motion. That in electrical, some conductors, what? Free electrons will be there. Only those free electrons, they set into motion to form that electric current. Then only negative charges are moving. Then what we can say here? The electric current, it flows from negative to positive terminal in reality. But still we are showing here from positive to negative. Why? Because in olden times it was believed that positive charges will move, not negative charges. Like that it was believed. So from then onwards, conventionally it was shown from positive to negative terminal electric current flows, it was shown, and it is called conventional electric current. Okay, so it has been the practice there, but in reality it is opposite, right? This is all about electric circuit. Now you see here, same it is written here. What? A closed continuous path of electric current is called an electric circuit, otherwise We can also define it in this way. What? A closed conducting path of electric current through a switch, a bulb, and a source of electricity through ammeter here, according to this circuit. That is also what? An electric circuit. Okay. Now we have studied about what is electric current, what is SI unit, everything we have finished, just related to electric current. Next we have to know what is potential difference. Okay. Now, potential difference, why we need to study that one? See, electrical charges, they do not flow by themselves in any metallic conductor there. See, if you connect an element of a circuit, electric circuit, an element of electric circuit means anything. Just if you connect with a source of electricity, the charges start flowing there, right? For flowing, something energy has to be spent, some work has to be done to make that electrons move from one point to another point or not. Some energy has to be spent. That is nothing but work done there. So now you see, for example, in this only we'll take here from one point to another point. If you are moving a charge from here to here, that is electric current, right? To move this charge, we need to do some work. That is only what? Work done in moving a charge. For a given charge, to bring it from one point to another point, we need to do some work. So that this ratio of work done divided by charge gives us what? Potential difference. Now, this potential difference, it is denoted with a letter phi is equal to W by Q. You see here, this is what? Potential difference it is. Potential difference, since there is no place, I have written in short. PD means potential difference, that is phi. Phi is equal to W by Q. W means work done in bringing a particular charge from one point to another point. Okay, means what? To make that electric charges flow from one point to another point, what we are spending that energy, that is what? Work done. That work done for a given amount of charge or unit charge, to bring that unit charge from one point to another point in a conductor, work has to be done. That work done for unit charge is it gives us what? It gives us potential difference. Now you see that potential difference, this should also be measured in a special unit, using a special unit. What is the SI unit used to measure the potential difference? The SI unit used to measure the potential difference is what? Volt. See that volt, here it is written as volt. Why it is taken volt? 1 volt means, again there is how much? 1 volt. 1 volt is equal to how much? W means what? 1 joule of work is done. If 1 joule of work is done, to move a unit charge, 1 coulomb of charge, to move 1 coulomb of charge from one point to another point, if 1 joule of work is done, then the potential difference created is how much? It is 1 volt. So this is how we are measuring a potential difference. See, this potential difference, to measure this, again there is a device called voltmeter. See, voltmeter is used to measure the potential difference in any conductor there. This voltmeter, how it is connected in a circuit? If you want to measure the potential difference means little more clear idea I will give how it is generated. Here if I am holding here two pipes, if we one same pipe if I hold, water level, water it is filled already in pipe there. Here and here, if the both sides, if the water level is same, then there is no difference there. If I lift one of the pipe, potential difference is created there. So the water from this pipe, it starts coming out, right? This type of difference has to be generated between positive and negative charges in a metallic conductor. Then only they will set into motion. Okay, so when we connect any source of electricity, that generates, that gives that potential or difference there. When it creates a potential difference, then that negative charges called electrons, they set into motion, forming electric current. Okay, so now the voltmeter, which is used to measure potential difference in a circuit, how it is connected then? It should be connected across the terminals of that source of electricity. Now, how we are connecting here? Across the terminals. Directly we are connecting here, means across, not in series. Because of what? It is a potential difference between two terminals. Means what? One has to be connected to one terminal, the other end of the voltmeter has to be connected to the other terminal. Then only we can find the potential difference between the two terminals. If it is connected in series, we cannot get it. So that is why the voltmeter has to be connected in parallel with a circuit there. Okay, so this is how we connect what? A voltmeter in an electric circuit. Now we have learned what is electric current, what is an electric circuit, what are charges, what is the SI unit of charge, what is the SI unit of current, then what is the device used to measure the current, what is potential difference, what is the SI unit used to measure that potential difference, what is the device used to measure the potential difference, and how that voltmeter has to be connected in an electric circuit. All these points we have learned. You have to keep this remembered, then you can understand the further topics when we learn in this lesson. Okay, I hope you have understood this. We will continue in the next class. Okay, thank you.